Hey there everyone, in this lesson we're going to be talking about how we can create linear models based off of scatterplots and tabular data, or data that comes from tables. So first and foremost, let's do a quick little recap of things that we probably covered way back when in Algebra 1, maybe even touched on in geometry. So here you'll see I've got three different formulas. We've got the slope formula, point slope form, and slope intercept form. This is kind of the general progression that you're going to want to go through anytime that you are dealing with writing the equations of lines if given 2 points. So I have these kind of set out specifically in this order for a reason. So this one right here will be our first step, this will be our second step, and this will be our third. Okay, so first we need to figure out the slope between these 2 points here. So we'll say that this is our x1 and y1 with 2 and 5, and then 4 and 11 will be our x2 and our y2. So our slope formula is going to be the change in y divided by the change in x. So it's a quick little plug and chug here. Up top we're going to have our y's, 11 minus 5, all over 4 minus 2, change in x's. And that turns into, let's see, 11 minus 5 is 6. Over 2. So our slope is going to be 3. Hopefully no minds were blown there. All right, next we're going to get into our point slope form. Now point slope form, you need to have 3 pieces of information. You need to have an x and a y point, which we've got 2 to choose from, but I'm going to go ahead and use 2 and 5 just because those numbers are smaller. And you need to know the slope. Well, lucky for us, we just figured out that that slope was 3. So we have all the ingredients that we need. So let's go ahead and get going on this one. All right, so we're going to have y minus my y value, which was 5, equals my slope, which was 3, times x minus my x1 value. In this case, that was 2. So point slope form is done. Now to transfer that into slope intercept, all we're going to have to do is distribute our slope into those parentheses there and rearrange by adding 5 to the other side. So that's going to look like y minus 5 equals 3x minus 6. And then as promised, we're going to add 5 to the other side. Please excuse that horrendous penmanship. And we're going to get y equals 3x minus 1. So that process is going to come into play quite a bit as we go through today's lesson. All right, without further ado, let's take a look. So we're going to be talking about trend lines. A trend line is any sort of line that passes through our data, and it's going to be used to model and make predictions. So our scatter plots will only have a handful of data points, and we can create a trend line in order to make predictions about points that might not show up. Later on, we're going to talk about how we can use our calculator, and that's going to give us the regression line, or line of best fit. But in order to make a regression line, we need to have some sort of technology at our hands. That'll come up in a later video. All right, so the steps that we're going to follow as we go through our remaining pages here is first we need to make a scatter plot. So again, a scatter plot is just a little graph that looks like someone sneezed a bunch of points all over the place. And then using our scatter plot, we're going to create a trend line, or some sort of line that kind of describes the data. And then we're going to take 2 points that are on that trend line. And once we have 2 points on that trend line, we're going to create the equation of the line that passes through those. And once we have the equation, we can do everything we need to do. All right, so here's our scenario. We have a table that shows the percentage of U.S. households with internet access in a given year. Part A is asking, make a scatter plot and let X be the number of years since 1995. All right, so this part right here is going to be pretty important, and a lot of folks might accidentally overlook that. So years since 1995. What that's telling me is that I don't really want to use these years explicitly as they're stated. Instead, what I want to do is think of it as how many years since 1995 was that. So 1997 That was 2 years since. 2000 was 5. Oops, I covered this up. What is this? That'd be 6, 8, and then 12. So these are going to be the x values that we're going to be plotting. And then our percents are going to be the y values. Anytime you have time or years or minutes, whatever, that's almost always going to be your x value. All right, so I've gone ahead and labeled up the axes. So my y-axis is going to be the percents. I just counted up by 5s. You can count up by whatever you want, so that would be 5, 10, 15, 20, 25, so on and so on. I just wanted to make sure that we could incorporate my smallest value, which was 18, and I would showcase my biggest value, which is 67. I didn't want to leave anybody out. All right, and then my x-axis, I want to label it such a way that we can get from 2 all the way up to 12 without skipping anybody. Well, I'm just going to count up by single years, right? 5, 10, 15 on those bolded marks. All right, so step 1 is done. We've got our graph labeled. We're good to go. Let's start plotting some points here. We'll go green. Let's do that. All right, so first point is going to be 2, 18. 2, 18 would be just shy of 20, so like right there. 5, 41.5. So 5 and 41.5. Ooh, missed the mark quite a bit there. We'll say it's right about there. Okay. Next step, 6 and 50.4. So 6 and 50.4 would be right about there. 8 and 54.7. Let's see. And then 12 and 61.7. All right, you'll notice my points are not exact. I'm not expecting your points to be exact. Anytime we are making trend lines, it's almost impossible to have exact points. So what we want to do now is we want to try to create a line that, to the best of our ability, goes through those points. It might hit some of them, it might not. That's okay. It does not have to hit all of the lines. In fact, it might not even hit any of the lines. That happens. So here I've got my trend line sketched in. Yours could and very well might look different. Now what I want to do is I want to find points on this line that intersect one of the grid corners exactly. So I'm noticing right here I've got a good one that I could use. And then right here appears to be another pretty solid one. So those 2 points are going to be the ones that I use to make my trend line. So those points that I just stole, let's see, what do we have? That was 8, 50. And then we had 13, 70. And again, those 2 points that I just got, these 2 guys right here, were not anywhere on the table because I'm pulling those directly from my trend line. All right. So let's see here. Sketch a trend line, just did that. Choose 2 points on the trend line, write the equation, slope-intercept form. Cool. So I've got my 2 points here, and that's what I'm going to use to write here in slope-intercept form. So first I need to find the slope, change in y values, 70 minus 50. Ooh, that's supposed to be a 5. Sorry for the horrendous penmanship. Over change in x, 13 minus 8. Let's see, up top, that's going to be 20 over 5. Hey, clean number, sweet. I got 4. All right, once you have that, you're going to go into our point slope form. And in case you forgot what that looks like, the very first problem we did, there you go. So I know my slope. I'm going to throw this into point slope form. So I'll use the first point of 8 and 50. So it's going to be y minus 50 equals 4 times the quantity x minus 8. So y minus 50 equals, after some distribution, that'd be 4x minus 32. Add 50 to the other side. Let's see, what is that? 18? So we're going to have y equals 4x minus 18. All right. Now I skipped a problem or a question earlier. It says, describe what this scatter plot reveals about the relationship between years and percent of households. Well, what can we gather? Are things increasing? Are they decreasing? What's going on? And if we look at the trend line here, it appears to be a positive correlation, and even further, it might even be a strong positive correlation to say that we can say it's pretty reliable data there. So as years go on, internet access increases, and we're in the year 2020 right now, and internet's almost everywhere, so I'd say that holds true. All right, next up, interpret slope and y-intercept in context of the problem. Well, there's two facets here. First off, slope. Slope is universally going to be your rate of change. So rate of change. So since we have a positive slope, that means we are increasing year by year. Your y-intercept is universally going to be your starting value. Now with this problem, our starting value was the year 1995. So our y-intercept is going to refer to the value in 1995. So according to my trend line, the slope tells me there's approximately a 4% increase every year. And the y-intercept means that approximately negative 18%. Ooh, that does not make sense, does it? Of households have access to the internet. Now let's look at why does that not make sense. Oh, easily. Because I can't do simple arithmetic. That should be a positive, which means this would be a positive. Easy. All right, there we go. So about 18% of U.S. households would have internet. If we look at our scatter plot, my trend line, heck, my trend line even appears to cross over roughly at about 18, so that's pretty neat. All right, next it says use the equation that we have. So let me take this equation and kind of send it over. Oh, maybe not. Let's see. There we go. So let's use this equation to predict households with internet access in the year 2020. Hey, this year. Cool. Well, the year 2020, that would be 25 years since our starting year of 1995. So I'm not going to plug in 2020. I'm going to plug in... Oops, that's not what I want to do. I'm going to plug in 1995. Or sorry, what am I saying? I'm going to plug in 25. There it is. For X. All right. So we're going to have Y equals 4 times 25, and then plus 18. 4 times 25, that's going to be 100, plus 18, so 118% in the year 2020. Now when we phrase our answers, you're going to want to use proper sentences. So here's an example. In 2020, approximately 118% of households will have internet access. It asks us here, does this make logical sense? Well, no, you can't have more than 100%. But again, this is coming from our trend line, not necessarily the data. The data would eventually have to plateau out, right? Because we can't go past 100%, but we don't see that in our window. So that's why we're getting values that might not make too much sense, because this is based off of the trend line, not necessarily the actual data. All right, that is it for this lesson. Your homework on this one is going to be completing parts A through F on the worksheet that'll be posted online. And you know the drill. If at any point you have any questions, please shoot me an email. Good luck, have fun, be safe, roll tide.